Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing how to draw the 4 feedback amplifier topologies. This topic is from the feedback amplifier unit. The subject name is ECA. So to draw the feedback amplifier topologies, we must have idea about sampling and mixing. As you know that in our previous video we have seen about sampling and mixing. There are two types of sampling, voltage sampling and current sampling. If sampling is done at the output side of the amplifier, if it is voltage sampling, it is shunt connection. If it is current sampling, the connection will be series. Mixing is done at the input side. There are two types of mixing, series and shunt mixing. Series mixing means we need to place a voltage source at the input side, and shunt mixing means we need to place a current source at the input side. So there are 4 feedback amplifiers: voltage series feedback amplifier, current series feedback amplifier, current shunt feedback amplifier and voltage shunt feedback amplifier. Let us start with voltage series feedback amplifier. Okay. For a voltage series feedback amplifier, we need voltage amplifier as a basic amplifier. Voltage amplifier. There are 4 basic amplifiers: voltage amplifier, current amplifier, trans resistance, trans conductance amplifier. For a voltage series feedback amplifier, we need to take a voltage amplifier. Voltage amplifier gain is denoted by AV, voltage gain, and we need a feedback circuit or a feedback network. Feedback network is generally made of a resistive network. Feedback network of ratio beta. This beta is known as transfer ratio. Okay. Now we connect. For a voltage series, the first word tells sampling. Sampling means, what is sampling done? Voltage sampling. If it is voltage sampling, what is the connection? It should be shunt connection. For voltage sampling, this is the output side of the amplifier. We connect a load resistor RL. Now it is voltage sampling. Sampling is done at the output side. So how the connection is? Shunt connection. So we connect in this way. Shunt connection. So this is voltage sampling connection. Okay. Now at the input side, we need to do series. The second word tells about mixing. Series mixing. What is series mixing? A voltage source is to be placed and the connection is series. So we place a voltage source Vs at the input side. And how this connection is at the input side? It is series connection. Like this. Okay. So this is series mixing. So what parameter is observed here? Voltage Vf. How much is Vf now? It is, we are observing here the output voltage. So it will take part of output voltage. How much part? Beta times of V naught. So Vf is equal to beta times of V naught. And here we are observing the input voltage Vi, voltage source Vs. So this is how we draw a voltage series feedback amplifier. Now let us see current series feedback amplifier. The next one is current series feedback amplifier. The first word is current, that is the output. At the output side we do sampling. If it is current sampling, the connections are series connection. Okay. And the second word, series, is mixing at the input side. So at the input side, what is the mixing done? Series mixing. Current sampling, series mixing at the input side. If series mixing is done at the input side, the voltage source is to be connected. Okay. So output by input. What is output here? Current. What is input? Voltage. So I naught by Vi. It gives Gm. The ratio of I naught by Vi is transconductance. So based on this name, by the name we can decide what type of basic amplifier we need to take. I naught by Vi is transconductance gain. So we have placed a transconductance amplifier of gain Gm, and then we have connected our feedback network of ratio beta. At the output side, we have connected a load resistor RL. The first word is current sampling. Current means series connection. So we have connected it series like this. Okay, in this way we have connected this series connection. At the input side, we need to place a voltage source. A voltage source, plus minus. And how is the mixing done? It is series mixing. So we need to do a series connection here, like this. Okay. So current sampling means series connection at the output side, and series mixing. So connection is also series at the input side, that is, and we are placing a voltage source at the input side. So this is how we draw the current series feedback amplifier. What is amplifier used here? Basic amplifier, transconductance amplifier. Okay. Now let us see the next one. The next amplifier is current shunt feedback amplifier. So now let us see. The current means the first word indicates about the output. What is done at the output of the amplifier? Sampling is done. What type of sampling is done? Current sampling. If it is a current sampling, what connections are to be done at the output side? Series connection. Next word is shunt. This tells about the input side. Input shunt mixing is done. If shunt mixing is done, what source we need to place? A current source. Current source is to be placed. Okay. So what is the output parameter here? I naught. And what is the input parameter? II. So I naught by II means its ratio is current gain AI. So for designing current shunt feedback amplifier, we need a current amplifier. Current amplifier of gain AI. Okay. And then we need to place a feedback network parallel to it. Feedback network like this. Now the connections we have to do as per the topology name. Feedback network of the ratio beta. At the output side, we need a load resistor RL. How is the connection at the output side? Current sampling. Current sampling means series connection. So we have to connect it series like this. So this is series connection. And at the input side, shunt connection. So what type of source we need to place? A current source. A current source IS. And how are the connections at the input side? Shunt connections. So like this we need to do the connection. You have to darken this circle, okay, this point, or else it won't be clear. Is this the wire connected to this or here? Now when you darken it, it means that this point is connected to this point. Okay, so in this way we can easily draw current shunt feedback amplifier with current amplifier. Now let us see the next amplifier, voltage shunt amplifier. The next amplifier is voltage shunt feedback amplifier. So the first word indicates about the output, second word tells about the input. At the output, what we do? Sampling. What are the type of sampling we have done? Voltage sampling. If it is voltage sampling, what is the connection to be done? For a voltage sampling, what connection? Shunt connection. At the input side, we are doing shunt mixing. If it is shunt mixing, which source need to be placed? A current source. Okay. So what is the output parameter? Voltage. What is the input parameter? Current. V by II. V by I is R. Rm. Trans resistance gain. So we need to place a trans resistance amplifier. Trans resistance amplifier of gain Rm. Okay, and a feedback network of ratio beta. At the output side, we connect a load resistor RL. What is the connection at the output side? Voltage. Voltage sampling. For voltage sampling, what is the connection? Shunt connection. So in this way we do the shunt connection. This is voltage sampling. At the input side, it is shunt connection, shunt mixing. If it is shunt mixing, what source we need to place? A current source. A current source Is is placed at the input and we connect it here like this. Okay. So shunt at the output and shunt connection at the input. So we have drawn a voltage shunt feedback amplifier topology using a trans resistance amplifier. So there are 4 feedback amplifiers: voltage series, next one is current series, current shunt and voltage shunt feedback amplifier. The basic amplifier for voltage series is voltage amplifier of gain AV. Current series amplifier, we need to use a trans conductance amplifier of gain GM. For current shunt, the basic amplifier used is current amplifier of gain AI. Voltage shunt, trans resistance amplifier of resistance RM. So till now we have understood what are the basic amplifiers and what are the different feedback amplifiers. So 4 basic amplifiers: voltage, current, trans conductance, trans resistance. 4 feedback amplifiers: voltage series, current shunt and voltage shunt. I hope you have understood how to draw each feedback amplifier topologies. If you have any queries, you can post them in the comment section. Thank you. Good luck, students.